guys, welcome to Bar Z. My name's Stan, and I was doing a repair for a customer, and I got about halfway into it, and I thought, hey, this would make a good video. So I apologize, I'm already neck deep into this thing, probably more than halfway. But let me explain to you what it is. It's a cast iron repair, and it's a repair on top of a repair. And I had to do a little investigative work to find out what caused the failure and when it failed, if it was someone moving a machine and they broke it, or it just broke under normal use. And I did a little investigating with the customer, had a few conversations with the operator as well as the owner of the place, and these two cast iron arms broke under normal working conditions. It's not subject to a moving damage or tipping over or anything like that. And what they are is there are a couple of channel arms that hang out of the back of a hydraulic shear. These are the adjusting arms for the backstop of a shear. And most of you guys know, but if you don't know, I'm going to tell you. The backstop of a shear, 90% of them move with the blade. When the blade comes down, the backstop moves up and down with it. So these arms hang out of that rear arm and actually are cycling through there. They've got a mounting plate out on this end. This is what bolts to the actual shear, and then this hangs out, and then there's a gearbox down at the bottom with a cross shaft and a lead screw in each one of these channels, and there's a bunch of weight hanging out there, and that thing's cycling constantly. So they snapped right here, both of them. And someone had done a nickel rod repair, and I welded it back up with nickel because I don't want to switch boats midstream, so I did do that. But then after seeing a repair fail, I knew that we had to do something more. So what we did, we built a channel inside. We actually cut 2-inch flat bar, cut it down so it fits correctly on the height and the width and everything. And then we had to get in there with a mill and mill out all the draft and all the flashing and all the scale and everything out of the inside of this casting, so our pieces would fit in there properly. And I don't know whether you can see it or not, but I've got countersunk screws all mounted subsurface there. I've got 4 bolts here, I've got 2 bolts here, and I've got another 5 down this side. And then everything's welded together down the whole inside. Now that's done and bolted and finished and welded. And this is the slider. There's a lead screw that goes down the center of this channel that goes through this nut. This is how you take your backlash out of the nut and do your fine adjust through that slot. And then I had to make sure everything stayed subsurface here so that my slider would make it up and down here and miss. It's very, very close, but we do clear. So you had to use a very specific thickness of flat bar, and I had to make sure none of my screws were sticking out, and just enough to give this thing some backbone. Now on this one, see if you can see over there. Yeah, you can see it pretty good. I'm going to go ahead and pull this channel out. I haven't bolted this one in yet, and we fitted these channels right in place. This fits very tight, so we just made a kind of a weldment, a fitted weldment that bolts in there. And you can see here where we milled out we milled out our weld, where we made our weld, and we milled out the sides and got all the draft and casting flaws and everything out of there, and made it so this channel fits in there very tight. And now it's going to get clamped up and get on the mill, and we go through and we drill and tap everything. We drill clearance in the cast iron, countersunk in the cast iron, and then tap the steel and draw it all together. And I think this is going to be a good, long-lasting repair. This is our break point here. This is where all the stress is, and we've bridged that substantially on the stick out. And even on this one, I can show you what we did here. This one actually has a cavity up inside. We made a 5/8 block that went in there, and then these 4 cap screws here go in and capture that, and those stay subsurface because this is where it bolts up to the actually bolts up to the machine. Now there's an awful lot of load on these 2 rear bolts. They're half 13 bolts. So we went, I don't know if you can see it or not, but we went through and helicoiled all those. But these 2 were completely failed, and these were working their way out, and the back 2 screws just weren't doing anything. And the whole thing was kind of flopping, as well as the brake. It was just a big mess. And the operator was getting frustrated because he wasn't holding his tolerances on his sheet metal when he was shearing it. All right. But the welds, just to hold the casting together. It's not gonna, if I left just the weld alone, there's no way it would stand up. We just needed a backbone. And then we got the backbone in there, and it's pretty darn tight. It's been you know, challenging to make sure all the sliders fit, and everything drops in, and those things work their way back and forth, you know. So everything had to be done in a very specific way to get this to work. All right, maybe I'll bring you back. Maybe we'll do some helicoils together or something. This one hasn't been helicoiled yet, so, or maybe we'll do some mill work or something. All right, but let's push in on a little farther with this. Okay, here's a little tighter shot of the channel. This was interesting. These 2 castings are not the same. I don't know if you noticed here, but there's kind of a little 45 here on the casting, and that kind of mimics itself down over here. And what they have out there is a stainless steel scale that bolts down there with a pointer that runs on the slider, and that tells them, you know, what their backstop length is. And so I wasn't able to make a straight channel. This piece had to follow. You can see where we milled this side here, and we just kind of went in there with a little die grinder and knocked all the scale and flashing off there and flattened everything out. But we actually had to create that profile right there in the part, right here in this corner. We had to create the profile, and there's the double welds down there. So this one was challenging to do, and these welds are not by me. I've got a new employee. His name is Chris, and he's doing a wonderful job. So that piece fits great. We're going to take it over to the milling machine and drill and tap some holes and get a bolt pattern in there, sides, top, everything. And then at that point, we can check this slider. There you go. We can check this slider to see if it's going to interfere, or if we need maybe a little clearance or machine work to the bottom of that. All right, but this other one didn't. This one fit pretty good. Got no clearance issues. It slides back and forth very nicely. So the lead screw is going to fit in there fine, and this part of the machine can go back together. Okay, so there's a setup on the mill. We're up on 246 blocks, risers. You know, we had to get it up high enough so we could get it up on clamps. I've got it just barely off of the weld repair, so that weld doesn't get in my way. And I've got it set down, you know, on blocks and everything right on these machine surfaces, so everything's flat. And did a quick tram because we're just running a bolt hole pattern down the length of this thing. You can see here we've put a pattern in down here with these countersunk Allen-headed bolts. I think these are, the way these index in there, I think these have better holding power than a regular cap screw with a counterbore, because it sits on the flanks, so you're working off of angles. So I think these will pin the cast iron much better. All right, that's just my theory. I have nothing to support that. All right, but now we just run down here. I've got a Sharpie mark way down here. That's where the end of my channel is. So I'm going to come up with a bolt pattern, drop some in the top, and then we can flip it and do the sides, and go from there. Okay, so that's the end of this setup. We can break this down. We don't have any more to do on the top. The rest of our work's on the side, which is completely different. And it's kind of an interesting setup, so I'll show you how that works. But the only reason we got these up on big risers is just so we can get clamps under there, keep that channel tight inside. And now we're bolted and we don't have to worry about it slipping. So let's get set up on the side and I'll show you how that works. Okay, so you know all those people that make fun of the holes in the 1, 2, 3 blocks and the 2, 4, 6 blocks? There's a use. T-nuts in the slots, studs sticking up. These are bolted down to the table and trammed in where they're both parallel with the axes of the machine, and when you sweep across one and get a 0 reading, when you come to the next one, sweep across it, you get a 0 reading. I got them within a half a thou. That's close enough for what we're doing. But this gives you a solid 90-degree surface, same as an angle plate. I mean, I could use angle plates too. I've only got one angle plate. I don't have 2 angle plates, so 2, 4, 6 blocks are wonderful. We're going to lay a couple of 1, 2, 3s down and bring our part back over here and get set up to do our sides. And this is how it's going to work. So we've got these rails down the side so we can get it parallel this way. We've got a machine surface down this back side, which is parallel this way. So all we do is bring them in here, set them down on the 1, 2, 3s underneath, and clamp it back into that. And literally a C-clamp and a C-clamp, and we're drilling holes here. And when I go to flip, no big deal. Flip it over and clamp, and then work over here. Simple. I mean, it's such an easy setup after you've found a use for your 2, 4, 6s, or it's any angle plate. If you got a pair of angle plates you can bolt on, that's the way to do it too. But this is the way we can get in here and get our hole pattern drilled and do our milling. Remember, we got weld buildup here on this rail, so I got to get some milling done in there too. So I need a good strong connection. I'm going to be using diamide clamps right on this open area here where I can get in here and work and do my drilling and milling. So here we are, fixtured in, clamped tightly to the 2, 4, 6s, and then we're using these little fellows underneath as kind of parallel blocks just to keep this down. I'm going to reset these and get them so that they, as I tighten here, we tap down. Very similar to what you do in a vise. You know, as you're tightening, you tap it down to make sure it's secure. And then we can get in here. I don't know if you can see, we've got an awful lot of weld buildup right here. And this rail is where the slider runs back and forth. So we got to get in here and mill that out. At least this little corner right here. So the slider still works, all right? And then also drill that bolt pattern. Okay, so that's how you fixture quick and easy using your 2, 4, 6 blocks and utilizing the otherwise worthless holes within your blocks. Okay, well, we're on our 3rd hole. We're on the other side of the break. I've already done 2 in the main pad. We're going to get another hole here. I'm checking, I got a new camera and I'm checking lighting. My last 2, I had this light on and it was pretty harsh. And I think it's better without the light on and just letting it autofocus there. So I think that's a lot better. And I'm using my wireless mic and trying not to yell like I usually do. So we're gonna go ahead and do this operation. I've got a diamide clamp pulling the channel together, and then I'm using diamides up against these blocks to fixture the part. And it's real easy to drop in, so I can move it around, move the clamps out of my way for my holes and stuff. So they're real easy to reposition. So let's get started on this. This is a multi-step operation. We're going to start off with a spot drill. Remember, we're going through cast iron and steel both. So we're going to start off with just a little spotting drill. I'm just going to use a center drill, spotting, center, either one will work just fine. And we're going to use a dab of anchor lube on the end, just because it's a flimsy little guy. I got it set up so I don't have to change speeds on the head. We're going to use back gear for a couple of the operations, and we're going to use direct drive for a couple of the operations. All right, so we're spotted. Next up, we're going to put a tap size hole through there. The bolts we're using are 3/8/16. And in cast iron, I'm not going to use any anchor lube, but as soon as I hit steel, I'm going to pull out and use a little bit of lube on it. And you can immediately tell the difference as soon as you hit that cast iron, or as soon as you break out of the cast iron, you can feel the difference in the steel, and you can see the difference in the chips too. All right, so now we've got a tap size hole all the way through. Next up, we're going to go with clearance and drill through just the cast iron. And you can completely, like I said, you can completely tell the difference when that drill bit touches the steel. You can feel it. The next two operations are back gear only, so we're going to countersink. And this is the point where you can see the rigidity of your setup. Countersink usually makes your parts walk around. This one looks pretty stable. I don't see any movement. All right, we're going to grab a bolt and check our countersink depth, but it looks like we're good. Yep, I think we got a winner there. Yeah, maybe just a touch more. All right. Next up, tapping, and that's another low speed operation. A little bit of anchor lube out at the tip of the tap, just so it gets down in that steel. And we're using a gun tap because it's a through hole, and we're sending the chips out the bottom. And a little bit of compressed air to get rid of the junk in the threads. And we're ready for a bolt. I'm just keeping an air ratchet here on my bench. And you can feel that steel pull into the cast iron. There it is right there. All right. So that's the end of that one. I need to keep working my way along. I'm not going to bore you with the rest of them, but I wasn't happy with the first two camera takes where we did the first two bolts. So like I say, new camera, hooked up to a lapel type mic, so I'm trying to train myself not to yell into the microphone. Okay, well there's the setup again with the part flipped. We're ready to do our bolt pattern again, and we're ready to do our carve out of our weld buildup. So I didn't change this at all. These two blocks are still where they were. All I did was flip the part over. So this has been real good for both of them after I finally thought on it for a little while. Sometimes if you're presented with a problem, you're better to sit down, get a cold drink, think about it a little bit, and come back to it. These kind of solutions don't always present themselves right away. All right, so I'm ready to start drilling. You've already seen it. I'll probably bring you back for the final fit up, getting the lead screws in and getting those sliders put in and make sure all this fits together right, and then the repair is done. It's ready to go back to the customer. I still got some helicoils to put in here, but easy enough. Alrighty, Yeah, I'll bring you back one last time. Okay, I thought I'd show you the helicoil operation. For those of you that aren't familiar, these holes were these were badly damaged, and I'm just going to put it in all of them. It's so easy, it's not even funny. So they've been drilled out, but how do you know what size drill to use? What you get in your first helicoil kit, when you first buy a kit, you get a special tap, you get a package of inserts, and then you get an insertion tool. And then after that, you just buy the refills. This is the kit for half 13. This is kind of like a spring, and the wire is a square wire. Well, not exactly square, it's 60 degrees to match the threads. So what we're going to do is we're going to line up the tap and a tapping block right there and get that started. And I'm going to get a clamp, and with my third hand I'm going to clamp it down. So we're going to use a tapping block by Big Gator Tools, and that's going to keep our tap nice and square on there. I didn't do it over on the mill. I probably should have when it was set up, but I forgot all about it. We're going to give the tap just a little bit of lube. I've got mixed emotions about using lube on cast iron. If the dust, it's dust, look at my hands. It's high carbon, it's dusty. If the dust is getting out of your way, do it dry. If you need to suspend it and wash the junk out of your way, then use oil or some kind of lube, a small amount of lube, to try to suspend it and get the dusty crap out of your way to clear your tap, your drill, your reamer, whatever operation you're doing. But your tools are going to wear no matter what. You're going to get the same wear on your tools, lube or no lube, with cast iron. It's so gritty and it's so sandy, and like I said, tons of carbon in it. You're not going to save your tools by using lube. It's just going to make your cutting operation easier. You're still going to wear out your tools. All right. All right, so that's a tapped hole. And now we're going to insert our coil. And you'll notice here, this is the insertion tool. This is a piece of plastic, but it's got a little metal tang right there. And you thread this on until that little tang right there lines up with it. It's going to catch right there. So it catches it from the bottom of the thread, and it's, as you're threading it in, it's squeezing that coil shut. And it's just as simple as that. Dropping in a helicoil. What we're going to do is we're going to put the end of our coil right here just below the surface and stop right there. And as soon as you back off, you can feel that spring, that whole coil is compressing as you're winding it in. And then when you release it, expands out into the hole. So that is a repaired half 13 hole. I'll go grab a bolt. We'll thread a bolt in there and you'll see how it works. There it is, half 13 bolt. And she just threads right in. And it's actually a pretty nice thread fit. Not bad. Okay. All that's left to do in the bottom, in the bottom there's that little tang that's in the bottom. You put a punch down there and you can pop that off, or get down there with a pair of needle nose and bend that off, that little tang that drives the coil in. But outside of that, that's how simple helicoils are. If you weren't familiar, thought I'd share. Okay, so we got our first one together. We're getting ready to put together the second one that I bring you along for the ride. Lead screws are identical. We're just going to drop a lead screw in, and then there's a couple things that have to go on. I've already cleaned thrust bearing, so it's a 3-piece thrust bearing with 2 hardened races and the ball cage. So there's one race. There's the ball race, or the ball cage. And there's the other piece of it there. So thrust washer goes in. We get a thrust collar. It's just a simple collar that with a pin through it, which is actually kind of a tight squeeze over this Acme rod. And then we get our slider. And these go in as so. And I'm just going to put, right now, I'm just going to put some light oil on the lead screw and get them ready to go in. And for speed's sake, I think I'm just going to put a nut on this lead screw and run it in with an air ratchet. Actually, I got an impact over here. All right, I could probably work with it there. I do need to get this thrust collar down the line a little bit. And you got to seat the bearing down here and the pilot for the screw up here all at the same time. My fat fingers don't fit down in there too good. There it goes. All right, we seated the bearing. And we had to get this pilot shaft in and the bearing all at the same time. We're ready to get the three-piece thrust bearing down where it belongs. And then the thrust collar. Looks good. And then all it is a roll pin from there. Make sure we got the lead in facing the right way. And we're pinned. Wow, that lead screw's bent. Look at that. Must have been when that thing broke. It bent the lead screw. It's wobbling right down there by the brake. If this was a Bridgeport or something, that would take exception to that, but it's just a shear. And no binding. And it's not binding up inside of there anywhere. That sucks that that screw's bent, but I think they're going to live with that. A little more light oil on these sliders. I'm not going to call them ways, or it's not really a machine like what you guys are used to. And this is on a hand crank. There's no way these are ever going to spin this fast. But I think we got a winner. We got no binding, our channels are tight. These things are actually ready to go back on. This one spins much the same way. No problems with this one either. You see, this lead screw runs real nice. Nice and straight that is. Yeah. Anyways, that's a drag about the lead screw. I don't think it's a huge deal. I'm going to just button it up and send it. You know, I don't think doing the hand crank that they really realize or will realize that there's that lead screw's bent. These things go really slowly when they crank that handle. There's a bevel gear here in the back. on each side. Can you guys see that? No, not really. These things sit about 6 feet apart, and there's a bevel gear that goes here and here on each one of these, and then there's a gearbox that goes right on the back with a shaft that crosses in between the two, and then there's a hand crank. You know, maybe on my Instagram I'll throw up a picture of this installed, and so you guys can see what it looks like on the back side of the shear, so it kind of lets you know what these things look like. But that's the end of this project. You know, mainly it was cast iron repair, just get them back together any way you can, and then reinforce them with a steel channel in each one and give them some backbone. And you know, when I fix stuff, I like to think that they stay fixed. So hopefully this is the last repair this thing's ever going to need. All right, guys, I appreciate you watching, and we'll see you on the next one.